The transformation we're talking about today is dilation. We're also going to be talking a little bit about scale factor. So a dilation is a proportional enlargement or reduction of a figure through a point called the center of dilation. So basically it's the center of the figure. The size of the enlargement or the reduction is called the scale factor. And this is where you hear people talk about, it's 2 times bigger or it's half the size. That's scale factor. 2 times bigger, half the size. Those are all the language of scale factor. Okay, a dilation, when we think of it, we think of when we go to the eye doctor and they dilate your eyes and your pupils get really big. Dilation in math could mean that something gets bigger, but it can also mean that something gets smaller. So dilation in math is either an enlargement or a reduction. Okay, enlargement or reduction. And if a figure stays the same size and the same shape, it has a scale factor of 1. And I'm going to abbreviate scale factor with SF. Okay? So anything that has the same size and the same shape, your scale factor is 1. That means you multiply the measurements of the first figure by 1 to get the second figure. So those numbers don't change when they get multiplied by 1. Okay? Now, if the scale factor is more than 1, then your figure is going to get bigger. So if my original side of my square is a 2 and my scale factor is 2, then I need my second figure to be 2 times larger. So my next figure is going to be a side of 4 because it's 2 times larger. My scale factor was 2. Same thing with a reduction. If I start out with a figure where my side length is 2, and now let's say my scale factor is less than 1, it's half. I want the second figure to be half the size. So I have to multiply by a half or divide by 2. So on my second figure, I better draw it smaller. On my second figure, my side length is only going to be worth a 1. So this scale factor was 2 because I multiplied by 2 to get from my first figure and to my second figure. And this scale factor is 1/2 because 2 times 1/2 is 1. So this scale factor is 1/2. Okay, this figure is half the size of that one. This figure is twice the size of that one. So we talk about our original. Okay, so a figure and its dilated image are always similar. That means they have the same shape, but they're different sizes. They're still proportional, but they're different sizes. They have the same shape and the same angle measurements. Okay, so your rule for dilations is to dilate an image and make it larger or smaller. You're going to multiply by the scale factor. Both coordinates of your ordered pair will get multiplied by the scale factor. Let's take a look at that. All right, so we're going to use straight edges for all of these. We're going to make a triangle, and our pre-image without the primes will be dilated by a scale factor of 2. So we're going to use a scale factor of 2 to complete the table and graph the original and the new triangle. So first let's graph the original. We have -2, -3, so starting at 0, that's -2, -3, -4, 0, -4, and 0. So this was A, that was B, and C is at 0, 1. So here's C. Okay, here's my original triangle. And obviously I don't have a straight edge, and I don't even have any lines on my tablet, so I have to try to figure that out. Okay, ooh. All right, so there's my wacky triangle to start with. Now, to create a scale factor of 2, I have to multiply everything in my pre-image times 2. So this is going to be -2 times 2 and -3 times 2. -4 times 2 and 0 times 2. 0 times 2 and 1 times 2. Okay, so my post image here is going to be -2 times 2. That's -4. -3 times 2, -6. -4 times 2 is -8. And 0 times 2 is 0. 0 times 2 is 0. 1 times 2 is 2. So let's take a look at our new triangle where that would go. And it should be 2 times bigger than the original. So -4, -6. -4, -6 for letter A, prime. B prime is at -8. This kind of goes off here, so we'll estimate 0. B prime. C prime is at 0, 2. Excuse me. So you can see that this second triangle is about squiggly lines, 2 times larger than that original one. Okay, and I'm sure your drawing will be much better since you're using a straight edge. Okay, a scale factor of 1/2. So we're going to take everything multiplied times 1/2. For our original image, we're at -4, +4 for letter A, -4, -4 for letter B, 4, 4 for letter C, and 4, -4 for letter D. So here's our original. Please use your straight edge. I don't have that option, but it's easier to follow these lines than it is to do a triangle. I can tell you that much. All right, so here's my original. Now I have to take everything times 1/2. My scale factor is 1/2. So multiplying by 1/2 is actually the same as dividing by 2, but let's take a look at how we could do this if we didn't know that. -4 times 1/2. Whoops. And then we're going to comma 4 times 1/2. Okay, notice these are all 4s. So once we get the +4 and the -4 figured out, we'll just be able to fill in the post image. But -4 times 1/2 and -4 times 1/2. You can also use the decimal form of 1/2, which would be what? Times 0.5, and 4 times 0.5. Okay. So you can do, if you know the decimal equivalent, you can certainly do that. We don't need to use calculators for this. We're not using calculators for our graphing. Okay. All right. So then we're going to figure this out. So -4 would be -4 over 1 times 1/2. Multiply your top numerators together, -4 over 1 times 2, which is 2. So -4 times 1 is -4. 1 times 2 is 2. Then we reduce it. That reduces to -2 over 1, which is the same as -2. So letter A here is -2. And obviously this is just the positive side, so this is going to be +2. Then we have -2, -2. If we do 4 times 0.05, we end up with, oops, sorry, 2. All right, so I put the decimal in the wrong spot there, 0.5. Okay, so we end up with 2 here also. So this is going to be 2, 2, 2, -2. All right, now we're going to graph the post image. So -2, -2, I'm sorry, -2, +2 for letter A. -2, +2, A prime. B prime is at -2, -2, B prime. C prime, +2, +2, and D prime, +2, -2. Notice how our new image, our post image they call it, is half the size of the original. The side length is half the size. So this had a side length of 8, and this has a side length of 4. It's half the size. All right. Now, I want you to answer these questions in your notes. How did the pre-image and the post-image compare? According to the length of sides, we just said it was half. What about the angle measurements? Okay, so the length of sides is half. What about our angle measurements? They're still all 90 degrees, so the angle measurements are the same. Our perimeter, if we have a side length of 8, side length of 8 times 4 is 32. And a side length of 4 times 4 would be 16. So our perimeter is half. Okay, area, 8 times 8, length times width is 64. And side length of 4 would be 4 times 4, which is 16 again. This is 1/4 of the area. So our second image was 1/4 of the area. All right, finding scale factor of similar figures. So these two items are similar. We're going to find out what their scale factor is. And to find a scale factor, if we can look and see if there's a common number to multiply between the original and the new, then that makes it easy. But sometimes you don't have that option, like on these figures here. So what we do is we find matching sides. For example, we have these two don't have decimals, so that's easy. We have AB matches up with PT. Okay? Now, we always put the new over the original. You remember from your percent proportions, the original always went on the bottom. Well, it's the same thing here. The original figure will go on the bottom. And I like to call this new because we don't want to use the word changed because that sounds like percent proportion where we subtracted, and we're not doing that. So new over original. Okay, so if our new one is 10, the original is 4 here, and that would be line AB is worth 4. So now we have 10 over 4. PT corresponds to AB. PT corresponds to AB. And then what we do is we just reduce this. So that would be 5 over 2, which would be 2.5. And written as a decimal would be 2.5. Okay? Or 2.5. You could either leave it either way, actually. Now, if we look at the ratios in decimal form, obviously it's 2.5. Now down here, PS corresponds to AD right here. So PS is worth 4 and AD is worth 1.6. Okay, so when we reduce this, it'd be 4 divided by 1.6. Actually, what I'm going to do is move it out to 40 over 16. So I just move my decimals one time to the right to get rid of that decimal. Okay, there are 2 16s in 40, and that'd be 32 that we're going to take out of here. And that'd be 8 16ths left, which we all know is 1/2. And so written as a decimal, it's a 2.5 scale factor. So this new figure is 2.5 times larger than the original. So once again, the scale factor of this dilation is 2.5. So we find our corresponding sides, make them into a fraction, new over original, and reduce it. And that's all you do to find scale factor. Remember, new over original, find one side of the new figure, 10, put it over the same corresponding side of the original figure, 4, and reduce your fraction. And that's it. That's scale factor. Okay, that's all you do for scale factor. Now you're going to complete your assignment on dilations and scale factor on your own.